Hello, so today I'm going to teach you a little bit about arcs and chords with the circle. So let's take a look at some arcs. So I'm going to talk about the major and the minor arcs first. So let's say, for example, you have the diameter AB and circle O. So I'm just going to plot some points here, C and D. So, okay, so let's talk about major arc. So a major arc is an arc that's located on the circle with a central angle greater than 180 degrees. So an example of a major arc would be, for example, arc A, B, D, because you have to go in order of the letters. So A, B, D. Since this has a diameter, this is going to be 180 degrees. Major arc means that it's bigger than 180 degrees. A minor arc is very similar. It's an arc on the circle with a central angle that is less than 180 degrees. So an arc on the circle with a central angle less than 180 degrees. So an example of that would be arc AC. Arc AC is less than 180 degrees. So now let's take a look at some properties with arcs and chords. So arc in a circle or in congruent circles, if two arcs are congruent, then their corresponding what are congruent? Well, we're talking about arcs and chords here, so the corresponding chords are congruent. And we are going to look at an example down here because we're going to take a look at the example down here because the converse statement is also true. So let's take a look at the example down here. In a circle or in congruent circles, if two chords are equal, then their corresponding arcs are congruent. And again, a chord is any segment whose endpoints are located on the circle. So let's take a look at some chords here. Okay, so let's say these two chords are congruent. Our theorem says that if these two chords are congruent, then their corresponding arcs are also congruent. So just to make it clear, if two chords are congruent to each other, then their arcs are also congruent to each other. The chord is not congruent to the arc, but the arc is congruent to the other arc. In a circle, if the diameter or radius is perpendicular to a chord, then it blanks the chord and the arc. Well, it's going to bisect the chord and the arc. And now remember, bisect means it's going to cut it in half. So let's draw an example here. We have a chord. Let's draw a diameter. And we're going to, that's perpendicular. So we already know that and that's perpendicular. So we know that since the diameter is perpendicular to the chord, it's going to bisect our chord, and it's also going to bisect the arc. Again, this piece is not equal to this piece. These two arcs are going to be congruent, and these two pieces of the chord are going to be congruent. Let's take a look at an example. So in circle X, AB is going to be 30. So we have AB equal to 30. CD is also going to be 30. So those two chords are congruent. And we know from above that if the two chords are congruent, then their corresponding arcs are also going to be congruent. And the measure of arc CZ is 40 degrees. Find each measure. So it's asking us to find AM. Well, we know from the theorem right here that since the radius is perpendicular to the chord, so it's going to cut it in half. And we know it's 30, so it's going to make it 15. 12. Find the measure of MB. Well, same thing. If AM is 15, MB is also 15 since it's cut into 2 equal halves, and the total is 30. CN. Again, these two chords were congruent. That there's a radius that bisects this chord. So these are going to also be congruent to each of those. So again, CN would be 15. ND would also be 15. Now to find, well, we know that the radius being perpendicular to the chord bisects the arc as well. So if the measure of arc CZ is 40 degrees, then ZD is also going to be 40 degrees. Measure of CD. Well, since we know CZ is 40 degrees and ZD is 40 degrees, the measure of arc CD is just going to be those two added together, which makes it 80 degrees. And measure of arc AB. Well, we know if two chords are congruent to each other, then their corresponding arcs are congruent to each other. So since AB is congruent to CD, that must mean arc CD is congruent to arc AB. So we're also going to get 80 degrees here. Last but not least, the measure of YB. Well, this chord is bisected by, so that means this arc is bisected by the radius. So we're also going to get 40 degrees here. So that's it for your video for today. Thank you.